on Sapling or on Google Classroom, but it should be very similar to all the Sapling questions that you've seen so far. So online people, if you're watching this video, which honestly I don't think you are, I'm making these videos every day, and I don't think the internet security is letting anybody watch them. So I'm just speaking into the void. Yeah, I'm trying to get that fixed, but the internet guy is on vacation all week, so there you have. Huh? He's in Vegas. I don't know. I just people who take trips to Vegas have like a chaotic mind that I don't understand. It does. I don't know that I would consider it fun. I mean, I understand that lots of people do, and I'm probably in the minority. But going to Vegas seems like a nightmare to me. Give me like a national park or like a beach or something. Yeah, I don't want to be like in a crowd of like thousands of people, and I especially don't want to go to an entire city that's like its sole purpose is literally just to take money from me. There's a very small amount of people that walk out of Vegas with more money than they came in, and I don't think I would be one of those people. So, yeah. I'm not gonna be a Las Vegas person, I don't think. And right now the Stars are playing Las Vegas, so I don't want anything to do with Las Vegas. That's not what I'm after. I need some Dallas Stars action. So what we're gonna do today, we're gonna go over dimensional analysis. I don't know if y'all can see this as well, but close your Chromebooks. I'm going to start to see if I can do the PowerPoints with the lights on. Because some of y'all, maybe not y'all in particular, maybe later in the day, but yeah, the lights go out and then the eyes start to close. And some of y'all, like me, are good at sleeping while sitting up. You keep your head straight, like you get your neck locked in, and you're just like sitting straight up. I had the same problem, even in college. Like the PowerPoint's on and the lights are off. And even if I want it and I'm like trying to stay awake, my eyelids get heavy and like my blinks take very long time and you can't open your eyes after you blink. And yeah, we've got to make sure that we're paying attention to this stuff, especially this stuff, because we're going to be using this literally all year. And so when it gets down to the tough stuff, we got to make sure that we're understanding what to do. So I'm going to go ahead and real quick move to the dimensional analysis part. Just got to get the tap, tap, tap going. Here we go. So I did already go over this before in class, but I will do some more examples today because we're talking about dimensional analysis. So this is going to be some math work. It's not going to be too hard. And, once you get it down, you can do it pretty quickly. But it is something that you need to be used to. This is not the last time you will see it. This is not only with chemistry. You might see this kind of stuff in your math class. You will definitely see it in physics. Some of y'all will need to take physics before you get out of here. And any of y'all that go into college, you will use this a lot. And you will use this in your real life too. To be fair, once you get out of school and you're allowed to just look stuff up, you can Google pretty much any kind of conversions. But sometimes you need to do conversions, and you want to make sure that you're doing it right, and you want to kind of understand it. So I do conversions all the time in kitchen. How many tablespoons is teaspoons, and converting from cups to gallons or quarts or whatever. And if you understand how to do this on paper, you don't always have to write it down on paper. Sometimes you can do it in your head real quick. You don't have to pull out your phone. And if you're cooking, you got meat juices on your hands and flour or whatever, and you don't want to be touching your expensive cell phone. So this is important to use. It's important to know. And if all else fails, you'll need it for this class literally for the rest of the year. So make sure that you're paying attention, and I'll kind of go through it where everybody can understand it. So dimensional analysis, a better term for this is unit conversion. You're taking a number in one unit, like feet or meters or grams, and you're converting it to another unit, like feet or meters or grams. It depends on what you're using. So it's a problem-solving method that determines a relationship between quantities by using their units. And what you need is that conversion factor. And I mentioned that a conversion factor is just a fraction with the top being equal to the bottom, and so the fraction is equal to 1. So if I have 4 quarters, 25-cent pieces, and I have $1 bill, the top is equal to the bottom. The numbers aren't the same, but the value is the same, and so this whole fraction is equal to 1, which allows me to use it to convert to different things. Let me bring this over here for the online people. So I have 4 quarters over $1 is equal to 1 as a fraction. So they're going to show you some units, and I know I went through this a little bit yesterday. I'm not going to spend much time on it. But they're going to show you some conversion units. So some of these we know, like 1 foot is equal to how many inches? 12 inches. 1 pound is equal to 16 ounces. You might know that. If not, now you know. So if you order a 16-ounce steak, you have to eat an entire pound worth of meat, which is actually quite a bit. You will be full afterwards. 10-ounce steak, that's plenty, especially if you got like steak fries and baked potato on the side. That's plenty of meat right there. Time, we all know time, and time actually is one of the good things. We all use the same time all over the world. You don't go to a different country and they're using a different time setting. Time is time. We all use seconds, minutes, and hours. We might use different words for those names, but the concept and the numbers are all the same. It's not like metric versus imperial system. Volume, we will actually use quite a bit of volume in this class. You can have things like cubic centimeters, cubic meters. You can have liters. CCs also stands for cubic centimeters, which is, I don't know why they did that. 1 cubic centimeter is equal to 1 cubic centimeter. But when you hear, like, does anybody watch a doctor show on TV? They have the doctors and they're like, I need 20 cc's of this medicine stat. Cc's is cubic centimeters. So now you know that. That's a little piece of knowledge for you to keep in your head. Energy, we will talk about energy at the end of the year, not this calendar year, but the end of the school year. We get into calories. Know that chemistry calories are food calories. When you say you have a certain amount of calories that you eat when you drink a soda or you eat a bag of chips, that's literally how much heat is your body going to have to produce to eliminate those calories from your system. And if you don't do that energy, if you don't do that work to create that heat, then it's going to store those calories as fat in your body. And if you do the calories, you do the work, you're going to work all that off and you're not going to gain any weight. So when we talk about calories in the heat section later on, it is actually, it's not the exact same as your big C calories, which is your food calories, but it is an equivalent. I think it's just like 1,000 more or something like that. And then we get into pressure. We'll deal a little bit with pressure, but not a whole lot. So there's lots of different ways you can do pressure. Atmospheres, which is literally how many of Earth's atmospheres are above you. At standard sea level, you have 1 Earth's atmosphere above you. So 1 is the standard one. We'll talk about the pressures later. I don't need to get into those today. So steps for using dimensional analysis. They're going to give you the steps now. Step 1's a doozy. Set up a mathematical expression to multiply what you know by your conversion factor, which is equal to 1, such that the current units of the measurement will cancel out. And that's what you want. You want to get rid of the units that you're currently in, and you want to get into the new units. So they will cancel out with the same units of the conversion factor and replace the original units with the converted units. So you want to get rid of your old units, get into your new units, and you use that conversion factor to do that for you. Step 2, repeat the process in step 1 until the measurement is done. Sometimes you will only need 1 conversion factor, and it gets the job done, and you can move on. Sometimes you need to stack them together. So you might remember towards the beginning of the year, I said how many seconds is in like 2 days or something like that. And I had to start with 2 days, and then I had to do several conversion factors. Let me bring my Chromebook over here so the video gets it. I always forget about the video, people. Sorry, video people. So you got your 2 days. I want to move days into hours. So I say 1 day is 24 hours. And I have the days on top and bottom because top and bottom can cancel out. But I'm not to seconds yet. I don't know how many seconds are in an hour, but I know how many minutes are in an hour. So I make another conversion factor with 1 hour on the bottom. Now I have hours on the top and hours on the bottom, and that gets me to 60 minutes. And then now I can go into seconds because I know how many seconds are in 1 minute. It's 60 seconds. And so for this one, I actually had to set up 1, 2, 3 conversion factors instead of just using one. So sometimes you'll have to string together a bunch of them. Sometimes you'll just be able to get the job done with one conversion factor. It depends on the problem and how you have to set it up. So step 3 is probably just going to be when the correct units have been reached, do your actual math. Multiply the values, or if they're on bottom, divide by them until you get to your end answer. And the only unit left is the unit that you actually wanted to have, which is your correct unit. So, example, how many ounces are in 35 grams? So we're converting grams to ounces. You need to set up your expression. They do that here, 35 grams, and then they have their equivalency. They're going to kilograms first. That's maybe not necessary, but we're going to follow along. So they say grams, if I have 1,000 grams, that's equal to 1 kilogram. So this fraction right here is equal to 1. So I'm not really changing the value of my number. I'm just changing the number in the units itself. So they're going to do this, repeat the process until they're done. Now they're going to go from kilograms to pounds. They're going the real long way around this. So 1 kilogram is equal to 2.2046 pounds. And then they'll go pounds to ounces. How many ounces are in a pound? 16. So they're going to set up one more with pounds on the bottom to 16 ounces. You can cancel out your units now. Grams will cancel out with grams. Kilograms will cancel out with kilograms. Pounds will cancel out with pounds. And the only thing you have left is ounces at the end. So they do that. You do your math. 35, divide by 1,000, hit enter. Times 2.2046, hit enter. Times 16, hit enter. And your answer at the end is 1.2. And the only unit you have left is ounces. So you have 1.2 ounces in 35 grams. That was kind of a long way to go around that. You could also look up the equivalency between grams directly to ounces. Probably would have been a lot shorter of a problem, and you would have only needed one conversion factor instead of 3 ones. So if you can make a shorter problem, make a shorter problem. Don't go the long way around. And that's it. They didn't go through too much in this PowerPoint. So go ahead and get started on the assignment. I will actually try to pull it up real quick and see if there's any problems I expect y'all to run into. Go ahead and get started on this. Let me actually go back. I want y'all to see everybody's grades. So let's see, there are 11 questions. Student preview. So what do we got here? Burette contains milliliters, grams. Oh, okay. So on this one, what they're telling you is initially this burette had 11.41 milliliters in it. They dripped some of that liquid out onto the scale in the beaker until it read 131.47. It initially was at 108. So we got to do a little subtraction, and then we need to get the density. That's what they're asking us for, is density. Does anybody remember what the formula for density is?
Mass over.
Yeah, mass over volume, yes. So density is mass divided by volume. Need a B, not a 4. Mass divided by volume. So that's what we need to figure out. We need to figure out the mass, we need to figure out the volume, and then we need to put those together. So looking at the problem, they tell us that your beaker starts out 11.4. Know that on your problem, you might have different numbers. So if you need to, get a piece of paper out and write these down. If you need a piece of paper, let me know. I'll bring you one. I got some extra paper. So on mine, I have 11.41 milliliters. And then what does it tell me on the beaker, on the burette over here at the end? It's not 11.41. I have 28.5, 28.6. I'm going to say 28.65 because it's not quite to 28.7. So I'm going to say my burette is at 28.65 milliliters. So I need to set up a subtraction here with 11.41 milliliters. That's right, 11.41. And I need to get the difference. So I'm going to do a little bit of subtraction and find out what the difference is. That's going to be my volume at the bottom here. So I'm going to get that answer and put it at the bottom. Now I need my mass. So the mass starts off at 108.31 grams. And it ends up, you can see down here, at 131.47 grams. Does everybody have these same pictures, or y'all got different numbers? Y'all got different numbers. So you might have different numbers. It's going to work exactly the same way. You just need to do subtraction, and subtraction is not that hard. If you don't want to do subtraction, stop being so lazy. It's literally just subtraction. It's not that bad. It's not hard. It's subtraction. So you're going to subtract these numbers, and you can use a calculator. Like, remember, I'm never going to be mad at you for using a calculator. You don't have to do it in your head, but you might have to write it down, which is not that hard. So you're going to do the subtraction here, and this answer is going to go up to the top, and then your last step, you just need to do some division. And so this is not a super long problem here. This is going to be 4, 2, 7, 1, and this one's going to be 6, 1, 3, 2, boom. So I've got 23.16 over 17.24. You divide those. For those of y'all that at home, if you're watching this video, your numbers may be different. If you have the same numbers, congratulations. I did some of the work for you. But if you have different numbers, you got to do your own. Does anybody want a piece of scratch paper? You don't have one? Dude, just let me know. If anybody wants me to bring you a calculator, let me know. I'll bring you a calculator. But that's your setup for problem 1. Let's see. The rest of them are probably not going to be too hard. So in this one, they have the problem set up for you. You just need to set up your conversion factors. So they want to know 383 miles per hour. If you're going that fast, they want to know how many feet you're going per every minute. So I need to turn miles into feet, and I need to turn hours into minutes. So how many feet are in a mile? Do y'all know? Or could you guess by looking at these? 5,280. That's right. Y'all got it memorized, which is nice. 5,280 feet per 1 mile. So when I set up this conversion factor, if I have 5,280 feet on top and 1 mile on bottom, that's going to be the conversion factor I'm looking for there. Bring this over here so they can see. And then I need to convert hours to minutes. If hours is on bottom, I want it to cancel out, so I put 1 hour on top. And how many minutes are in an hour? 60 minutes. And so you see that the miles cancels out, the hours cancels out, and the units I'm left with is feet over minutes. So I just need to do my math here, which is 383 times 5,280 divide by 60, and my answer goes in right here. So you got to have these set up correctly, and you got to have the right answer in the answer box. Miles per gallon. You go this many miles. They want to know how many gallons. This is just regular kind of division. If you need help with any of these, let me know. We got a temperature one. We got kilograms one. And you know what? We may, depending on how well everybody does on this, we may have to pick this one back up after the test. This looks like it's going to take a little while. You might have to do a little bit of work, but we're not going to spend more than 2 days on it. So make sure you're working on it. If you need a piece of paper for scratch paper, let me know. If you have questions, let me know. I can work something on the board and kind of show you how to do it and show everybody how to do it. But I got the first 2 problems kind of worked out for you. So try to get those done and let me know if you need some help. Yes. Huh?
Just do it at the end of class.
Right now the due date is, but I will probably end up extending that. If you get it done and we end up having to spend another day on it Tuesday, after the test on Monday, then you won't have anything to do Tuesday and you'll have a free day, which is nice. So be working on it. I'm turning this light back on so y'all can see stuff. Yes. We got. Flip that other one because you have hours on bottom, so to cancel out, you want your hours on top. Yeah, so minutes goes on bottom and hours goes on top. So you multiply the 7, you take 717, multiply by 5280, and then divide by 60. So multiply the 2 top numbers and then divide by that bottom number, and you can ignore the ones. The ones won't change. Let me see what you got. So here, try again. So you got this one right, where you need to flip it. The hours needs to be on top, and the minutes needs to be on bottom. So now you got your hours into minutes. On this one, you want to go from miles to feet. So you want to put the 1 mile on bottom, and then it should be 52,800 feet. Yeah. And then so the math you're going to do is 275 divide by 60, hit enter, take that number and multiply by 5280. So if it's on top, you multiply. If it's on bottom, you divide.
Yeah.
And you can ignore the ones. It's probably going to be a lot because 717 miles per hour. So you're probably going to be going a lot of feet per minute. You divide it by 60, right? Mm-hmm. Cool. Yeah. Sometimes it's big numbers. You got to trust your calculator.
That he did.
On which one?
I don't know if I can do it for the first one.
That looks like it could be right. Mine might be. What numbers did you get? This was your weight, and that's your volume. Yeah, that looks right. Yeah.
What around it too, though?
In general on sapling, give me 2 numbers past the decimal, and that usually will be okay for you. Good job. Yeah, I will say that again over and over this year. If you're not really sure where to round it, generally 2 numbers past the decimal and sapling will be fine with that. It'll give you the right answer. Yes. Yes, yeah. So you put the 120 on top, yeah, and the 110 on bottom. Yep. Yes, yeah. What is that? That's my phone. Why is my phone making sounds? What is this? My phone like opened some app I've never even seen before. It's making like leaf blower sounds. What was that? that it? It's like Google listening to me. What was this? I don't know what that is. Okay. No bad deal. If you have questions, let me know. I'll have to work through a problem. We'll work it together on the board. Did you get it wrong? Let me see. Oh wait, this is a different problem. No, it's that same problem. Hit try again. Let's see. So you did 12.35. Let me see your picture. Oh. Hold on. Where'd you get the 9.11 from? Oh, this. No. The 12.35. Oh, wait. I see what you did. Wait, 110. And then make this big screen so I can see it. 110 and 120. Yes. All right. So here, the 12.35, you need to subtract that from this number, which would be like 28.5, 0.6. It's not quite 28.7, so make it 28.65. So do 28.65 minus 12.35. And that should tell you what your volume is here on the bottom, where that 3.24 is. Yeah, so replace that and then do your division, and that should get you the right answer.
Right.
Yes, 9.11 over 16.30. And if you want, these calculators are faster. Look, y'all, don't be afraid to use the calculators. If you want me to bring you one, I will. They're way faster than opening up a new tab on your computer. Yeah. Okay, let me see what you did. Let's see. So you got, wait, are you subtracting these? All right, so that's what you got to do. You got to make this big. You got to do the 120.08 minus the 112.58. And then you got to do, you got 28.65. Yeah, 28.65 minus the 212. So see up there, I was subtracting them first. And then you take your two answers and then divide those. And bring you a calculator. Yeah. Let me see. I can plug you in right over here.
Milliliters to liters, eh?
Did you get it?
No, it said it's wrong. But it said it's because it's 67, not 65.
Oh, they're using 67. That shouldn't be that much of a difference, though. Anybody else wants calculators? Let me know. Huh? After you subtract it, you need to take the mass one, which is the hundreds numbers, and put that on top, and then take the volume answer and put that on bottom. So it needs to be your mass over your volume. Yeah, and then divide it. Mass divided by volume, and that'll be your answer. Let's see, because that doesn't seem right. You should be pretty close to that. So you did 28.67 minus 12.35. And you got, let me move this over. And you got 16.32. Okay. And then the other one was 9.11. So let's do 9.11 divided by 16.32. Oh, you had the right answer. Look, let me show you what I was doing. It was in scientific mode. So you're taking this but it has this times 10 to the negative 1 over here. So actually, if you put it in flow, you kind of have to go back and forth sometimes. That's your answer, 0.5582. So you had it right. You were just off on your decimal. So move the decimal over in front of the 5, and it'll count it right.
Just tens place or what?
You can leave the 8 there. It's not going to hurt it. Cool. Good job. Here it comes. Yeah. All right. How'd you get that right? So what you need to do here, you have this one right, you just need to flip that. This hour is on bottom, you want the hour to be on top and the minutes to be on bottom. Cool. No problem.
51. How? 61. 71.
Hey, don't be quiet, you do your work.
Yeah, what year?
I'm guessing like 28 point. Well, it's past the 6 mark here. The big one's 5. So 6, 5, 6. I think it says 6, 7 is what it's looking at. So 28.67.
I'm doing this right.
Yes. Yeah. Now, the only thing is that number. You want the 120 to be on top and the 130 to be on bottom. Yeah. No, you're good. Yeah, put the big number on top and subtract the 113.
No wonder you don't actually.
Divide 17 by 643. 7.5. I got 46.
Well, on this? It might be, yeah. Right, 0.46. Yeah, that seems about right. Because she had a decimal up there, less than 1. And that worked for her. Don't be afraid to try answers. Seth can help you out. So let's see. Oh, so they want miles per minute. So here, let me show you how to get this one.
Oh yeah. Is this number 10?
Huh?
This is number 10 that he asked for?
What number are you on there?
You're right. 10.
It's number 10? Yeah. Let's do it. All right. If y'all want, we'll do number 10 on the board. Yeah. So, we'll grab this. We'll do number 10 on the board. Because this one, let's see. Number 9, number 10. Speed of light in a vacuum is 3.00 times 10 to the 8 meters per second. What is the speed in miles per minute? So our distance is meters. We need to turn that into miles. And seconds, we need to turn into minutes. So let's come over here to the board. I'm going to flip the lights back on. We need to turn the speed of light into meters. No, miles per minute. So we have 3.00 times 10 to the 8 meters per 1 second. So that's how many meters it goes in 1 second. Let's start with the time because we know the time already. How many seconds are in a minute? 60. If I have seconds on bottom, I want to put seconds on top. So I'm going to have 60 seconds here and 1 minute here. Now I need to make one more. I need to turn meters into miles. Meters into miles. And actually, let's see. Let me come over here and do a little more. I don't know how many meters are in a mile off the top of my head. So I'm just going to Google it. Meters per mile. So in 1 mile, there's 1,609.344 meters. So I'm going to set that up. I have meters on top, so I'm going to put meters on bottom. So I'm going to have 1,609.344 meters and 1 mile. So that is my problem right there. Now, what am I going to do to get this answer? I'm going to have to put this in the calculator. Got my trusty calculator here. So when I put this in, I want to put brackets around this. This one should be fine, but you want to get in the habit of putting brackets around your numbers in scientific notation. And know that to do an exponent, you have to put a little caret. It's a little like rooftop. We call it a caret. That'll get you into exponent on these calculators. So I'm going to do open bracket 3.00 times 10 with the caret to the 8th power, close my bracket. And now if this is on top, am I multiplying or dividing? Multiplying times 60. And then if this is on bottom, am I multiplying or dividing? Dividing. Divide by 1609.344. Hit enter, and boom, I have the answer. And I'm not going to give you the answer. You have to put it in a calculator. Why would I give you the answer? I literally wrote all the problem out for you. All you have to do is type it in the calculator. Y'all love to hit buttons on your Chromebook. Hit some buttons on your calculator. I'll bring you a calculator. I can't be bought. I can't be bought. I have integrity. I'm rich with Dallas Stars wins. What's a calculator?
I guess I'll have to do it.
Yeah, they might lose, but right now they're way better than the Rangers and the Cowboys and the Mavs. So I can live with that loss.
The Cowboys don't even have this.
This is their year.
Yeah, that's what everybody's been saying. I stopped watching the Cowboys a couple years ago. My life has never been better.
I'm with you.
You already have one. We got. Convert the length to but here. These are better. The ones on the Chromebooks aren't that good. I'm telling you. Listen, I'm telling y'all, get used to using these calculators now. The ones on your Chromebooks are going to make you take way more time than you need to take. Convert the length to its equivalent in nanometers. Oh, and this one, nanometers, meters to nanometers, is just going to be 10 to the 9th. So you should be able to take that exact number. Check it out. That's 10 to the 9th. You should be able to take that exact number, whatever they give you, and just put times 10 to the negative 9th at the end. And so if you put that into the answer box with the number they already gave you, that's your answer. Because you're going from meters to nanometers, and nanometers is times 10 to the negative 9th. Now, to put that in the box, I don't know if you see this. What number is that? 7? Yeah, so here, when you start to type, wait, hold on. There's one extra thing you got to do because it's 0.009. So actually, hold on. 9.3. Oh, I don't want you to do that. Okay, so actually, you need to do it this way. Nanometers is times 10 to the negative 9th. So you're actually going to have to move the decimal on this one and type it out. So you're going to have 0.00933, right? That's your number? So you need to move this 9 times to the left. Yeah. So you're going to do it 1, 2, 3, 4, 5, 6, 7, 8, 9. Add all your zeros in. And so you're going to have 9 plus 2, so 11 zeros, and then your number. And that's going to be in nanometers. And that's for number 7. Yes?
I need help. I need to know if it's right.
Let's see. Is that right? Speed, miles per minute. I don't know if it's right. You gotta put it in the check. Yes. Yes, it's speed of light is fast. It's gonna go really, really fast. So you're talking miles per minute. It's probably gonna be a big number. Yeah, that's the thing to remember. Y'all all, for a lot of these problems, y'all all have different numbers. So I'm not gonna know whether your number's right or not, but I will be able to tell you if the size is okay. Flip the hours and the minutes, because you have hours on bottom here, so you want hours on top to cancel out properly. Yeah, and now that's good. So you're gonna take this, divide by 60 times 5280, and that'll get you your
I
answer.
just need 1 to 3 and then 10 and 11.
divided by
I'm trying to
60.
send my mom the chicken.
Let me know if you need help.
That's where you are. 723.
Huh? No, because you did all the moving of the decimal, you don't have that 10 to the negative 9. Yeah. So normally it'll give you the option to put that in there, but it didn't on that problem, so I knew they wanted the whole decimal.
Wait, what?
Hold on a second, let me see. Good job. Let's see. And then how many you got? You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It says wrong.
My thing is wrong. It's kissing me now. You don't want me to give you I just kept them.
Oh, yeah, my bad. We went the wrong way.
I thought
So look, on number 7, see, even I mess up sometimes. On number 7, we went the wrong way with the decimal. You need to go the other way. Take your decimal here, go this way 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then put your zeros in and leave your decimal. Hello? Hello? Yeah. Yes, she is. Okay. Yes. Now she's here. All right, no problem. All right. Yeah. So on this one, you move it 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. Add your zeros in. Get rid of the zeros up front, and you should be able to put that in.
Plus 2.
Yeah, I got confused on the count.
If you press.
You honestly just gotta press plus 273.
Yeah. But if you press hit, it'll show you.
Yes.
What the?
I know.